Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying the session. Like we have done nearly 60 plus sessions. Hope you guys are enjoying and learning a lot. We are enjoying and we are learning a lot each and every day. Hope the same thing for you guys. So yeah, today is a coding session of SVM. So last session we have looked into the theoretical concept of SVM. So today we're gonna dive into the coding part of SVM. So guys, before coming to the session, make sure you guys watch all the previous session videos so that you guys can have a better understanding of what we are talking. Okay. So yeah, if you guys have any doubts stuck anywhere, just ping us in the comment section. We are here to take up. Okay, and we will solve your doubts. Okay. So without wasting any time, let us dive into today's session. Today's session will be very simple session. So we're gonna see the coding part of support vector mission. Before going further, if I say support vector mission, what is coming to your mind? Okay, just ping in the comment section. Okay. Okay. Hope guys, if you guys have watched previous two session, we have explained you the black box behind the support vector. Okay. Let me know. What is mean by support vector? What is coming to your mind when it is called a support vector? Okay. Yeah, I'm revealing an answer. It should be a hyperplane. That's it. Okay. Based on the hyperplane, we're gonna classify or gonna perform the regression. That's it. Okay. Let us dive to today's session. Today's session is a coding part of support vector mission. Okay. So first thing first, we're gonna import the necessary libraries. It's simple. Okay, we have seen I think nearly 3+ coding sessions, so it will be similar to that. Okay, so guys, before that, it's an environment. It's a collab environment. If you guys need more understanding of it, please make sure that you guys watch the Python session of us where we have introduced you about this environment. What is this environment? What are the things that we can do with the help of this environment? Everything we have explained. So make sure you guys have watched those videos so that you can have a better understanding of this environment. So simply it's a collab environment, really like a where you can run the Python code. Okay, yeah. So moving on, like you guys can see the first cell where we'll be having importing necessary libraries where we are having numpy. You guys know, right? It is used to perform the mathematical operation. Then we are having pandas where you can perform, you can add the data in a form of a data frame. Then you are gonna use the dataset from the sklearn library. Then we are gonna have a train test split. Hope you guys know what is train test split. If you guys doesn't know, please watch our sessions. Okay, where we have explained why we need train test split, what is train test split. Okay, then we are having something called as a from pre-processing. We are gonna import the standard scalar. Then SVM, I'm just importing sklearn.svm. I'm just importing the SVC. That means support vector classifier. Okay, we're gonna see the classification problem. Next, I'm just importing the metrics as accuracy score. Okay. Now, I'm going to load the dataset. That's an iris dataset from datasets that is which is available in the sklearn. I'm going to load it by using the load iris, and I'm going to feed it to the data frame like bd.dataframe of this iris is a variable. I'm just placing it whose data it is. Okay. Then I'm going to pass column name as iris.feature names. That's it. And I'm just passing this iris.target to the data of target column. You just see the column. Okay, like see the data set. We are having supple and supple with petal and petal and what is the target? That's it. Okay, guys, about this data set, it's a planned data set. I hope like we have introduced you this data set. I think in one of our coding session, it's an iris data set where we will be having the supple and supple with and petal with. Based on that, we're gonna say what is a species that it is, what is a kind of flower it is. Okay, the species belongs to the flower. Okay, the flower belongs to which species? Sorry. Okay, the thing is whether it is a setosa, virginica, or vesicular. So these are the three species. Based on this like I will say based on these coordinates. Okay, like what is a sepal and supple with and petal with. Based on that, it will gonna do. Okay, so moving on, like you guys can see, I'm gonna just print the summary of the dataset. Like shape, what is the shape of the dataset? We are having 150 records. Okay, and then 5 features. Okay, right. We are having 4 features and one target. Okay, we can call it a sepal and sepal with petal and petal with. That's a 4 features and our target variable that is output, which is target. That's it. So then I'm just printing the head of it. Okay, once I printed, you guys can see we are having head of it. Just the first 5 records. Okay, the first 5 records sepal with petal with, and then we are having target. Okay, hope till this no confusion. We have loaded, we have imported the necessary libraries. We have then loaded our data set and we have just summarized our data set. Moving on, let's see the pre-processing. So I'm just checking data as a data set name is null.sum, which will show how many null values on each and every columns. You guys can see there is no null values. Everything is zero. Okay, so there is no problem. So our data is very clean. let's move on to the next step. That's we gonna segregate our data set into input and output. What is our input? So we know, right? Sepal and sepal with, petal and petal with. These four columns are our input and target is our output. How we can do means from the data, I'm gonna drop a column called as target because that is what our output. And I'm gonna use axis as one. Axis one means it's a column. We gonna remove the target column and everything else is our input, that is X. And then what is our Y? Data of target. That is only the column which we removed, right? That is gonna be our output. That's it. Okay. Our input is all the column except the target, and our target column is our output. That's it. Okay. So you guys can see this is our X. So we are having sepal and sepal with, petal and petal with, and then our Y. So this is the target that we are having. That's it. We have split our data set into input and output. Hope you guys can understand. Now, moving on, let's see the shape. Okay, we are having 150 records and then four rows, four columns for the input. Sepal and sepal with, petal and petal with, and only one column. We gonna have the same 150 records, but one column for the y-axis. Now, I'm gonna perform the feature scaling by using the standard scaler. I'm just importing the library called as standard scaler. I will say the model. Okay, from the sklearn library, I'm just importing from pre-processing. I'm just importing the standard scaler. It's a model which is used to standardize our data. Okay, so scalar is a variable name. I'm just passing fit transform. I'm just passing my input and I'm getting the scaled output. You guys can see I'm just printing the shape, same shape. Okay, 150 comma 5 4 because sepal and sepal with, petal and petal, there are four features and we're gonna have the 150 records. That's it. Okay, we have reshaped it, like rescaled it. That's it. Okay, now I'm gonna split this data set into training and testing. So you guys already know. Okay, in order to train the model, we need the training data. Once training is completed, we need to test our model, so that we need a test data. Okay, you guys can see I'm just putting the test size as 0.3. That means 30% of data I'm going to use it for testing, remaining data for training. That's it. Okay, we're gonna have y train, y test, x train, x test, y train, y test. So you guys can see this is y train. Similarly, this is also one of the y train. Okay, so x train, y train. You can see the size, like how many data are there. 150 records. Here also 150. For training, we are using 15. Sorry, from 150 we are using 105 records for training. Whereas for testing we are having 45. So this is what the ratio of 70% for training and then 30% for testing, because we have mentioned it here. This test size is 0.3, right? That means 30% of data for testing. Okay, so the 150 records is like converted into 105 and then 45 records. Okay, now I'm going to load the model. It's a simple thing, guys. I'm going to load the SVC. That is mean by support vector classifier. Once I loaded the model to this variable, I'm going to train the model. Simple. Model.fit. Okay, what is my training data? X train, Y train. That's it. I have fitted the model. Once I fitted the model, I'm gonna predict the model. Okay, simple. Model.predict, and what is my X test? Okay, that is the testing data, and we're gonna get this Y pred. So this is what the Y pred that we are having. Okay, so this is what entire prediction that we are having, which is predicted by our own model. Okay, and let's see what is the accuracy that our model is giving. Accuracy score, and I'm gonna pass the something called as very simple thing. Okay, we're gonna pass. Okay, I will say something like we're gonna pass a simple thing like what is my okay, this test data. You guys can see the testing is this is a value which is present in the data set itself. Okay, hope you guys can understand. And whereas this y pred, it's a value which is present in the which is predicted by our model. Okay, hope you guys can understand. Okay, so I'm gonna pass this and I'm gonna see what is the accuracy of this this entire thing. Okay, like we're gonna have passing this accuracy score. It's a model kind of thing where we are passing y test. Y test is the value which is present in the data set, whereas y pred is a value which is predicted by our model, our own model. Okay, so these are two things that we are having, and then passing to the accuracy score, and you guys can see this is what the accuracy score, we are getting 100% accuracy. Okay, hope you guys can understand. Okay, now moving on, let's see, this is what iris dot target names. We are having target names as I have mentioned previously, like we're gonna have setosa, virginica, and vesicolor and virginica. These are the species that we are having. Okay, hope you guys can understand. Now moving on, let's see how we can do for a single prediction, like single data. Okay, how we can do that. Moving on, let's see, we're gonna pass the input. that is 4 inputs that we are needing. Okay, what is our 4 inputs? Sepal length, sepal width, and petal length, petal width. I'm going to pass. This is sepal length value, sepal width, petal length, petal width. So this is a single sample that I'm having. I need to convert to an array. Okay, np.array will convert this to an array form, and this sample will have the sample data. That's it. Okay, so now the sample is gonna have sample input. When I'm passing this, and I need to transform it, right? Because we have scaled it up. That's the reason I need to go for scalar, which is I need to scale in a form that a model can understand. Okay, scalar dot transform. I'm just passing the sample. Okay, hope till this everything is clear. I'm just passing to sample scaled. Then what is the prediction? So this sample scaled is our input now. We have the original input. I'm just passing the scaled input. Okay, because our model can understand that only. Okay, I'm just passing to the model dot predict, it will give the final prediction. That's it. So moving on, like we're gonna have the prediction, like whenever these four values are there, right, it belongs to 0. Okay, that means you guys can see here, right, setosa, versicolor, and virginica. 0 means, you guys know, right, this is an index. Okay, you guys can see array. So 0 means what, it gonna take this, right? So whenever we're gonna have this four values, right, sepal length, sepal width, and petal length, petal width, then it belongs to the class of 0. That means it is setosa. Okay, hope you guys can understand. So here you can see, right, setosa. So this is a target, like the final prediction 0, and this is what the final output based on the feature name. Okay, so yeah guys, this is what the entire flow that we are having. Okay, hope you guys can understand. So where we have started with something like model loading. Sorry, we have started with what are the importing necessary libraries. Okay, what are the libraries we need? We have moved on to the loading the data set, and we have gone for summarizing the data set. Then we have split our data set into input and output. We perform standardization, and then we have gone for train and test split. Then we have moved on to the something called as model loading, model training. Then we have predicted using the model. Then we have tested it, and we found what is the accuracy score. Then after everything we have done for a sample data. Okay, so this was the entire flow, guys. Hope you guys can understand. So yeah, this is what my side. I hope like sir gonna say some more extra things so that you guys can understand. So yeah, sir, over to you.
Yes, yes, guys. Just give me a second. Okay. Yeah. So, yeah, we are starting. Can we go to the slide from the beginning? See, guys, support vector machines. So we have to do this project, live project. So application. So we have to import the libraries. Import numpy as np, import pandas as pd, and select like from sklearn import dataset, sklearn model selection, import train test split, sklearn pre-processing, import standard scalar, and from sklearn.svm import svm. We have to import also support vector machines, right? So then we have to import sklearn.metrics, import accuracy score. These are very important libraries which we have to. Then we have to load the data set. So iris data set we are using, and which is equal to datasets dot iqad. Okay, iris. So then we have to again data equal to pd dot data frame. Okay, data equal to iris dot data, column iris, feature name, and data target value we have to define, and equal to iris dot data, a target, iris dot target. So this is how we load the data, the iris data. Okay, then we have data output. So we'll look at it. So it will be the according to that, sepal length, sepal width, petal width, and target variable. Okay, so this is how it will look, the behavior. So then we are going to summarize the data set, which would be we'll be writing print dataset shape, data dot shape. That is the command we have to give. Print, then print first 5 rows of the data. Okay, data dot head. Okay, so similarly you can do data dot tail also. So look at the lower portion of the data. Okay, so how it looks like. This is for just a summary to that, so that you look at the behavior of the data. Okay, let's move to the fourth point. Then we go to pre-processing, guys. Pre-processing, here the data set, we have to check the null values. We have to check in pre-processing, we have to do missing value, outliers, and other things. So here we are checking null values. So for that, print and checking for null values, print data dot is null bracket dot sum bracket. So you will get the null values. So we got the null values. Okay, then then we go and segregate the data set into input or output. For that, we have to define x equal to data dot drop target, x is equal to 1, which is the feature, y equal to data target, which is the target variable. Okay, so y is target variable, x is the data drop, like we have to do that, data dot drop target, x is equal to 1. So then you'll see sepal length, sepal width, petal length, petal width. So then you have, yeah, this is the behavior. This is how it looks like. Then you have, yeah, so I have 150 rows and columns, 4 columns, and target variable is like this. This is how it will look for this particular data set, guys. Okay, then we go to the shape. We'll write x dot shape, comma y dot shape. So always you have to look shape for the both the axis, right? You will not do shape only for x or y, both. Okay, so that the outcome is 154 and 150. That is the behavior outcome of this particular shape. So how it looks like. Then we are performing feature scaling. We have to perform that. Scalar equal to standard scalar bracket, then x scaled equal to scalar dot fit transform x. So this is how it will look, and then you have output, which is x scale dot shape 154. Okay, and then you have seventh point, which is splitting the data into a training and testing data. This is very crucial, guys. So whatever work you have done till now, so here you will be tested. Whether you are a great data scientist, AI/ML researcher, or engineer or scientist, here your actual this is the I have mentioned this couple of times. How many training layers you are training, those many zeros will be added to your salary or whatever project you are doing, because you will be known. This training is very, very important on data. That is very, very crucial, guys. So how we'll do that? X train X test, comma, Y train Y test equal to train test split X scaled Y test size equal to 0.3 random state 42. So so I've asked the question in previous session that what is state, guys? Random states. Okay. So, today I'll answer that. It is the number of times this will the training will happen. That is what is the random state. Like it will try to train the model 42 times. Correct? Raja, is it correct?
Yeah, actually, like random state is like from where the data is split itself. It's not like training step. It's like
No,
where the
but
data is
we
split.
have to we so this is not epoch, right?
Yeah, yeah. It's not an epoch.
Ah,
Yeah,
okay, okay.
it's
I
like
I
a
got that.
state.
Okay, okay. These are the random states. It will be the
Yeah.
different 42 states. Okay. Not okay.
Yeah. That's it.
Yeah, yeah.
Like
Okay.
it's like a seed in
So
it like a seed
we
in.
are not using epochs here for
Yeah.
this data set.
Mm. No,
So how
it
many
is like
times we have to like train that particular, because that will also depend, right? How good is the
yeah.
performance? We are not doing that.
No. It is like
Okay.
inbuilt. Like we are
Okay,
using the
okay.
default
Okay,
values.
this is inbuilt, right? That's why. So no problem. So when you guys, when you do for a live data, as I have done, so you have to do uh, number of epochs, okay? So that means because it will also take time to train your model, right? So how many times you want to, that is the number of epochs. So usually we do 100 epochs, 50 epochs. It depends on competition and how what is your data. So when you start project from zero, like from zero, you build model from scratch. Okay, so okay, this is inbuilt. So then we have x train shape dot shape, then x test dot shape, y train dot shape, and y test dot shape. So this is the behavior output, which is 105 4 45 4 105 45. So then we have to 8 point is loading the model, which is support vector classifier SVC, and model equal to SVC. We have to define that which model we are loading here, and then we have to train the model. Okay, then we'll do the training, guys. Then we do predicting. So that will be done YPRED. So we use this particular syntax equal to model dot. This is inbuilt, guys. So you just need to remember this, because there is no this is not rocket science. You need to remember these, because with practice you will get to know. So when you do synthesis, when you go and practice a lot, so you will get to know. So don't worry about that. Y predict equal to model dot predict x test. Okay, this is how you will, then you'll see y predict outcome. This is okay. So this array you got. So yeah, then we go to the 11th point, which is calculating the accuracy of the trained model, which is accuracy equal to accuracy score y test y predict print f model accuracy 100.2f percentile. So you have this, so you will get the accuracy for this. So this is 100, because see, it is inbuilt model, so it has been trained a lot of times. So usually you will not get 100%. So you'll start with 50, 60, 70, 80, and you have to do a lot of hard work. Because when I used, before 10 years, when I started my research, guys, I'll sleep till 5 a.m., 4 a.m., because until unless I'm not getting the optimal performance, I'll not sleep. So you have to understand that here, because it's an inbuilt model, so inbuilt data set, so you will get this. But you don't get if you're starting from scratch. So okay, so then we go to iris.target names, and then you have the array, which is Zetosa, Virginica, color, and Versica, and data type U10. Then we are predicting the outcome of single sample using the train model. Okay, and then we have the outcome, which is 0, and then predict class, which is 5, 3.6, 1.4, 0.2. That is Setosa. That yeah. So this is done.
Yeah, yes, sir.
It's
That's it.
all about this. So what you can do, guys, you can imitate this at an initial level and mimic what we are doing. Go watch again and again and do this application. Even if you do it 10, 20 times, do this, because then you will build your muscle memory for these terminologies, these things, and these concepts in application, and that will help you a lot, because you will get familiar, and that is going to build your skill set for a long term. So go and absorb the information, digest the information, and apply. So here you have to apply, do it 20, 30 times. Go mimic and imitate whatever we are teaching so that you will build muscle memory, not your memory, not your heart, not your soul, but entire consciousness of your body should know that these are the terminologies. Even if somebody in the night you're sleeping and somebody says, what is it? You should know what is the concept. Application will vary, guys, in real life, okay? Different projects, different things, but basic concepts never change, basic principles never change. So you need to master that. Okay, so technology will improve, but 90% I'll say will never improve because those are principles, those are concepts. 10% technology will improve, change, new version, new things. But concept, basic axioms and premises and basic concepts, basic logic remains same for the technology, guys. That you have to master deeply at a meta level. So go and watch all these sessions 5 to 10 times, absorb the information, digest and apply, do all the assignments. This is the assignment for you guys. Do this project and write in the comment section what have you learned, how you're applying, and what is your long-term objective function for your career. And become a lifelong learner. And also, guys, have patience, persistency, consistency, and perseverance. And these skills will help you to build long-term objective function and define your goal, because you have to define as soon as possible what you want to become, because then and only you will not be in confusion. You will work hard, and don't afraid for working hard and learning new terminologies and new things. Don't make perceptions. Be open for learning. Okay, be open. Okay, if you see a flower when it blossoms, it never gets biased to the environment. There is rain, there is dust, there is a lot of climate changes happening, but it is always blossoming in the uncertainty. And you also need to be like a flower, always blossoming in uncertainty. Uncertainty is there, but we need to blossom in uncertainty, and that's life, guys. Okay, keep doing it, keep learning deeply. Excellence, follow the excellence, everything will follow. Earning 2 3 crores package is not a big thing. If you have determined, you have persistency, consistency, long term objective function, and long term this, and you're doing hard work, and you're open to learning, not biased, and you're always welcoming uncertainty, and that is going to make you a great. So learn these things deeply, and keep learning deeply, and subscribe to our channel. Also press the bell icon so that you will get notification for each session, guys. Thanks, keep learning.
Yeah, guys. So yeah, this is all about today's session. Today we have just looked into the coding part of SVM. Hope you guys have enjoyed this. Okay. So I hope like now you guys get a like a flow of it, how everything works, right? We just need to do everything related to data in a first stage. Then we need to go for a model building kind of thing, training and testing, and then finally we go for a prediction. That's it. Now you guys know about the flow, okay? And you gonna guys know the black box of the model also, okay? So hope you guys are enjoying on like you're learning and improving your skills related to this AIML field. So hope you guys have a clear understanding. If you guys stuck anywhere or any doubts, please ping in the comment section. So yeah, guys, that's the thing. And guys, please like subscribe to our channel so that you guys doesn't miss any of our videos. So every day we will be posting a new videos. Okay. So yeah, guys, that's it from our side. Make sure you guys have a perfect understanding. Okay. So yeah, until next session, bye guys. Take care, and we will all meet in the next session. Bye guys.